Hi guys, welcome to the next lecture of trigonometric identities. In this lecture, I'll be going through a few solved examples. Okay, if you keep a pen and notebook with you, try to solve ahead of me, or you can pause the video and try and solve, because this will help you become more confident in the chapter. A few tips to keep in mind before this is firstly, though, you should be good with your formulae or keep a formula sheet with you. Alright, try to start with the more complicated side as most of these sums will be of proof type. Prove LHS is equal to RHS. If you do not know what to do, convert the sum in terms of sine and cos. Remember to look for identities like sine square theta plus cos square theta is 1, sec square theta is 1 plus tan square theta, like that. Remember to look for identities, and sometimes in very specific cases you will have to start with RHS side. Now let's move on. I'll display the first sum. PT stands for prove that. Okay, we'll be looking at some solved examples as I said. First sum is prove that tan A plus cot A is equal to sec A plus cosec A. Obviously, if you're doing this chapter for the first time, it might look tough, but in fact, this is a very easy sum. All you have to do is convert to sine cos. Okay, I'm going to take LHS. LHS tan A. Tan A can be written as sine A upon cos A, and cot A can be written as cos A upon sin A. Next step. What will I do? I will take LCM. LCM में what? Multiply this with this with this, and then bottom ka denominator ka multiplication becomes a LCM. So I will get sin square A plus cos square A upon cos A sin A. For those of you who didn't understand this step, let me repeat it once. First I multiply sin A with sin A, then I multiply cos A with cos A, and then the bottom LCM I multiply the dotted. I multiply these two. Okay, this is a very easy trick to find LCM when there are no numbers. The numbers hai to it's easy, but when there's no numbers, this is what you do. Now, for those of you who have noticed, if you've done the formula well, sin square theta plus cos square theta is 1. Or sin square A plus cos square A is equal to 1. Write the identity here. Sin square theta plus cos square theta is 1. Theta is any angle. In this case, the angle is A. So we can quickly write this as 1 upon cos A sin A. Now, they've asked us to prove sec A cosec A. Keep looking at your right hand side. Keep looking at what you have to prove. Now, we know that 1 upon cos A is nothing but sec A into 1 upon sin A is nothing but cosec A. I just split it up because it's a multiplication sign. So I took 1 upon cos A into 1 upon sin A, and that gives me sec A plus cosec A, which is equal to your RHS. That is how that cot A plus tan B upon cot B plus tan A is equal to cot A tan B. Again, if you don't know what to do, like you might see this, you might get confused. If you don't know what to do, convert the sum in terms of sine and cos. We know that cot A is nothing but cos A upon sin A plus tan B. Tan B is nothing but sin B upon cos B. Remember, angle has to stay the same. Huh? And cot B is nothing but, sorry, cot B is nothing but cos B upon sin B. And tan A is nothing but sin A upon cos A. Now the sum is very simple. All you have to do is add these two fractions upon add these two fractions. So as I told you, first we'll take LCM. Cos A cos B plus sin A sin B upon sin A cos B. This is LCM of the fractions in my numerator upon, again I'll take cos A cos B plus sin A sin B upon cos A sin B. Now remember this form. This form is like A upon B upon C upon D is nothing but A upon B into D upon C, denominator ka reciprocal. Okay, so once I do that, This is what I'll get. If we are doing it stepwise, this is what I'll get. Let me just write it over here. Alright. This is equal to cos A cos B plus sin A sin B upon sin A cos B into cos A sin B upon cos A cos B plus sin A sin B. How did I get this? If you're still confused how I got this is like A, this is like B, this is like C, this is like D. And then I applied this thing over here. I applied this thing over here. Now, very simple. If you notice, this term and this term are the same, so they get cancelled. And all we are left with is cos A sin B upon sin A cos B. Now, let's take a breather, look at what we want in the RHS. RHS is cot A into tan B. Now, इधर cot A दिख रहा है. Can you see cot A? Yes, I can see cot A. Where is my cot A? Look at this. This is my cot A. This is my tan B. Sin upon cos is tan, cos upon sin is. So we can get it as cot A into tan B RHS. This is nothing but your RHS. Move on to the next one. This This is a very simple sum. Okay, there's only one step which you need to know, the third one. For at the first strike, you won't get what to do, but this is my method of solving it. 1 plus cos A upon 1 minus cos A. I'll start with the LHS. Okay, I'll start with the LHS. Let's do into 1 plus cos A upon 1 plus cos A. I am just going to take the opposite of this. Okay, I took the opposite sign of this, either minus s, so I took plus, and to neutralize it, I did into 1 plus cos A. Basically, I'm multiplying it by 1. 1 can be written as 1 plus cos A upon 1 plus cos A, right? And anything into 1 is the same thing. So that's what I have done over here. And now it becomes pretty easy. You get 1 plus cos A whole square upon 1 minus cos square A. How did I get that? How did I get that? This is because of identities. A plus b into a minus b is nothing but a square minus b square. And now I will use the expansion a plus b whole square. That is in the next step I will use a plus b whole square expansion. Here I will use a square plus 2ab plus b square upon 1 minus cos square a is nothing but sin square a. How did I get this? Because remember I told you, remember this, sin square theta plus cos square theta is 1. So from here we get 1 minus cos square theta is sin square theta. That's what I have written over here. Alright, this is what I have written over here. Now I will just, since each term has a common denominator, I will split them up. I will write them as 1 plus sin square a plus 2 upon cos a sin a into sin a. I can write sin square sin a into sin a, and I will write cos a upon sin a whole square. Now this is very simple. What have they asked us? Cosec a plus cot a whole square. Now, if you notice, 1 upon sin a or 1 upon sin square a can be written as cosec square a because cosec a is 1 upon sin a. Next, I can write this as 2 cosec a cot a. And lastly, I can write this as cot square a. Let's quickly see why I've written it like this. Can you see the dotted line? This dotted line is nothing but cot or say upon sine A becomes cosec A, 1 upon sine A, 1 upon sine A becomes cosec A, and this becomes cot A. And 1 upon sine square A becomes cosec square. Alright? And this itself is nothing but your A plus B whole square. Okay, if I take cosec A as A, this is nothing but A square plus 2AB plus B square. So I can write this as A plus B whole square. Do you agree? And when I do that, I will write it as cosec A plus cot A whole square, which is my RHS. Very simple sum. All you had to do, it's a good sum because we use multiple properties in it, but all you had to do was multiply by the conjugate of the denominator. If you didn't get this step, you wouldn't be able to do it. The smooth sum is also a very good sum. Why? Because the proof doesn't actually start with the LHS or RHS. There is something that you have to realize before you start the proof. And now, this is how your thought process should work during the sum. I see sec, I see tan, I see cosec, I see cot. What should I think? I should think of these two identities. Identity 1 I should think of is sec square A is equal to 1 plus tan square A. And identity 2 I should think of is cosec square A is equal to 1 plus cot square A. Now, both of these have common 1. So I will equate for 1. So what I'll do, I'll shift tan on this side, I'll shift cot on this side. So I'll get sec square A minus tan square A is equal to 1. And I'll get cosec square A minus cot square A is equal to 1. Now since both are equal to 1, I can equate these two. So I'll equate them. I'll write sec square A minus tan square A is equal to cosec square A minus cot square A. Now that I equated them, pay attention. We will be using A square minus B square formula. A square minus B square is A minus B into A plus B. Agreed? Applying this identity, applying this algebraic identity, we will get sec A minus tan A times sec A plus tan A is equal to same identity on the RHS, sec A minus cot A, sec A plus cot A. Now if you see, look what we need. LHS, sec A minus tan A upon cosec A plus cot A. इसको नीचे शिफ्ट कर दो and take this and इसको यहाँ नीचे शिफ्ट कर दो. So what will you get? Sec A minus tan A upon cosec A plus cot A is equal to cosec A minus cot A upon sec A plus tan A. This is your final answer. This is your final answer, hence proved. So this was not an LHS and RHS type sum. It was just you can directly prove it using the two identities that we learned. Okay, keep this sum in mind. It was a good sum, not your standard type. Next, we will be dealing with root sums. I call these root sums. Why? Because you can see the root over here. I call these root sums. Now, in root sums, always start with the root part. Always start with the root part. Whenever we see a root part, we want to remove the root. And how will you remove the root? You will remove the root by rationalization. Rationalization. How will we rationalize? We will multiply the entire fraction inside the root with the conjugate of the denominator. So we will multiply both numerator and denominator with 1 minus sin A. conjugate of 1 plus sin A is 1 minus sin A. The conjugate. Conjugate means just flip the sign, change the sign. Alright, so I will be taking your LHS 1 minus sin A upon 1 minus sin A. Yes, this was the sum. Now, after we solve this, we will get 1 minus sin A whole square in the numerator. In the denominator, it is our standard A plus B into A minus B. Let me just make it color. A plus B into A minus B gives you A square minus B square. And what is A square minus B square here? It will be 1 minus sin square. Writing this 1 minus sin A whole square upon cos square A. Why? Because 1 minus sin square is cos square A. I hope you remember this. Why? Because sin square A plus cos square A is 1. We know this. So I shifted sign on this side, you get it equal to cos. Next, after removing the root, we will get 1 minus sin A upon cos A. So we did this entire thing to remove the root. And I feel this is our answer. Okay, this is our answer. Now it's very easy, just split the denominator. This can further be written as 1 upon cos A minus sin A by cos A. And this becomes a sec A minus tan A, which is equal to nothing but your RHS. Our last sum for today. This is a very brilliant sum, okay, because nobody actually sees what to do in this sum. Remember that whenever you see in this type of sum, whenever you see a minus 1, we have to play around with this. Remember, this 1 is equal to nothing but sec square A minus tan square A. And how did I get this? This was because sec square theta is nothing but 1 plus tan square theta. Alright, so I just shifted the tan square theta on the other side, and that's how we'll get 1. So I will substitute 1 as sec square A minus tan square A. Now look at this step, I'm writing it in pink because it is very important. Minus sec square A minus tan square A upon tan A minus sec A plus 1. Now over here, this we can write sec square A minus tan square is nothing but A square minus B square, and this can be written as A minus B into A plus B. So we will be using this in our next step. This becomes tan A plus sec A minus of, always put big brackets, A minus B into A plus B. This brackets clears your confusion. Upon tan A minus sec A plus 1. This A, actually I've written A minus B A plus B, sorry. I'll just write this in terms of tan and sec. So instead of A minus B A plus B, we will write sec A minus tan A into sec A plus tan A. This is the most important step. If you got this step, the remaining part of the sum will be very simple. Now, take tan A plus sec A common, or you can take sec A plus tan A common in the numerator. If I take it common, it becomes 1 minus sec A minus upon tan A minus sec A going down. Okay, now if you notice, I'll just highlight it with pink. This term and this term is the same, so it gets cancelled. What we are left with is sec A plus tan A. Now converted to sine and cos because we need a RHS in sine and cos. So 1 upon cos A plus sine A upon cos A. Denominators are same, so I can add the numerators. 1 plus sine A upon cos A. This is your RHS. Alright, let's check it out if we got the sum right. Yes, 1 plus sine A upon cos A. So guys, this is how these are some important solved examples. If you practice these again and again, you will get a hang of what to do. I will be solving more questions based on the exercise 21A. So stay tuned, guys. I'll see you in the next lecture. Bye bye.